Let's go through question 2 now. And I'd like to go through question 2 in two parts. In this video, we're going to go through the logic behind derivatives, first order, second order, convex, concave, and in the second part we'll actually apply all this logic into the example. So we have our function f of x equals to ln of x divided by x. Our domain is that x has to be positive because ln can only be of a positive number. And we want to find out the range where our function is convex and where our function is concave. Now, let's actually draw a graph and understand what is convex, what is concave, and how does the derivative help us with it. So if we have an xy axis, let's say xy axis, xy origin, let's draw the graph. Let's make it curvy so we have more examples to work with. We have something like that, and like that. Alright, so that's gonna be our function. This is f of x. Now, before we get to convex and concave, let's understand what is the first order derivative. What does f derivative of x show us? Well, look, what is f derivative of x? That's a slope, that's a rate of change. That's what the derivative proves. What is a rate of change? What is a slope? For instance, at this point over here, the slope, the tangent line, what does it show? It shows the change in y relative to the change in x, and that's our derivative. That's our derivative at that specific point. Now, what does the derivative show? Well, if the derivative is positive, it means that the change in y is greater than the change in x, which means that as x increases, our y increases as well. And that's literally what the first order derivative shows us, that if the derivative, the first order derivative is positive, the function is increasing. And when the function is increasing, well, the slope is upwards. And that's what we see here visually. The slope is upwards, it goes up. As x increases, y increases as well. Now let's take a different range. Let's take this point over here. What's the rate of change over here? Like that. This is the tangent, and let's say this would be our x value. So as x increases, let's say from this range, as x increases, what happens to y? Y goes down. So that means that the change in y relative to the change in x at that specific point is negative. As x goes up, y goes down. So let's write it here. As x goes up, y goes down, which means that the derivative, the slope is negative, which means that the function is decreasing. And that makes sense because visually we can see that the slope is downwards. So to sum up, the first order derivative, just f derivative with respect to x, shows us whether the function is increasing or decreasing. And that's it. That's what the derivative is for. We want to see how is the rate of change. Now, what is about convex and concave? That's where the second derivative comes into play. Now, to show the second derivative, let's draw a new graph. Let's draw a new graph real quick. Let's go over here. So if we have an xy axis, and we draw our function, let's draw it like that, here and here, we can see that the function is increasing. It goes up, right? As x increases, y increases too. It increases and then it still keeps increasing and then it flattens out. So the first order derivative is positive. The function is increasing. F of x is increasing on this range. Alright, that's fine. Now what do we still want to know? We would like to know how is the function increasing. Is it increasing at an increasing rate or is it increasing at a decreasing rate? So let me write this down. Is the function increasing at an increasing rate or at a decreasing rate? And how does that look like on a graph? Increasing at an increasing rate, that means that y increases more and more as x goes to the right or as x goes up. So as x goes up, y increases more and more. And we can see this, for instance, on this range over here. That as x increases, y increases more and more. The arrow goes straight up, so it kind of accelerates upwards. That's why we call it a convex function, a convex range, better said. This is a convex range. The function is increasing at an increasing rate. And when the function is increasing at an increasing rate, the second order derivative is positive. So the rate of change of the increase of the function is positive. Second order derivative is positive. What is increasing at a decreasing rate? That happens when the function is still going up, is still increasing, but it's increasing less and less. As x goes up, we can see that as we move along the x-axis, as x increases, our y value goes up, but it goes up less and less. It flattens out, and that's a very useful concept in business, in economics, because most things have a diminishing return. The more input we allocate to a resource, the more inputs, the more raw materials we use in production, we're not gonna increase our production linearly. It's gonna flatten out because there's only so much we can actually produce. So that's where the concept of diminishing returns comes into play. And that's what happens when our second order derivative is negative. We have a concave range over here. Concave. The function is increasing, but it's increasing at a decreasing rate. And I hope this whole theory and these graphs make sense. Please go again through both of the graphs on the video and try to draw them yourself to see how these ranges differ. And in the next video we're going to apply this logic to our example.